Hey guys, welcome to the Baby Cakes Diner. We're currently deciding what we want to use as our namesake, the baby cake. We're deciding between a quadratic, non-quadratic polynomial, trigonometric, or exponential function, and we need your help.
Great, thanks. I think we just need a few minutes to decide.
I love the sound of the trigonometric cake because if we look at the cross section of the cake, the height is around 7 centimeters, so the amplitude should be around 7, and because of the whole of the bunker, the equation should be shifted to the right by 3 units. And let's see, the cake has a width of 6 centimeters, so the period should be around 12. So the equation should be around y equals 7 sine of pi s over 6 minus pi over 2. And if we did the area of the cross section, we would have to use the FTC. And that would be an integral from 3 to 9. The area is around 26.738 centimeters squared. And the volume, we have to use the shell method. So the equation is around 1,008 centimeters cubed. And I think that sounds like a pretty good cake to me.
That sounds great and all, but I love the sound of the non-quadratic polynomial more. To find the equation of the non-quadratic polynomial, we use the vertex form with the 4th power, and then plugged in the vertex. However, we also needed to find the value of the coefficient, so we plugged in the 0 that we found earlier, and expanded the equation. After we found that, we got y equals negative 7 over 81 x to the 4th, plus 56 over 27 x to the 3rd, minus 56 over 3 x to the 2nd, plus 224 over 3 x minus 105. Using this formula, we can find the area of the cross-section of cake by finding the definite integral from 3 to 9, not equal to 33.6 square centimeters. We can also find the volume of the total cake using the shell method. It equals to 1,266.690 cubic centimeters. Obviously, this cake would be the best fit from the menu.
I don't know, I'm just really liking the exponential equation. It's fascinating. Like, how would you even imagine to get one like that? You need to take two EDX functions and use them together to make it. The first equation would need to be reflected over the x-axis and use transitions to move the knee of the curve into the first quadrant. And then the second equation, you need to reflect over the x-axis and the y-axis and use transitions to move the knee of the curve into the first quadrant. Even then, it's still complicated because in order you have to find the perfect values to make the equations fit the correct x-intercepts. After all that, you're left with the piecewise function, where negative e to the x minus 7.003 plus 7.367 is used for every x value greater than 6, and negative e to the negative x minus 4.997 plus 7.367 is used for every x value less than or equal to x. To find the area of the slice of cake, from there, you just need to integrate the equation, use the FTC, and then use algebra to solve, which gives you an area of 30.207 centimeters squared. Finding the volume is simple because all you need to do is use the shell method to revolve the area around the y-axis, which gives you a volume of 1,182.56 centimeters cubed.
Those are cool and all, but the quadratic equation is the easiest to make. The cross-section is modeled by the equation y equals negative 7 over 9x squared plus 28 over 3x minus 21. We found this equation by using the vertex form of a quadratic equation and plugging in the point 6, 7 as the vertex. This is the vertex because the cake is 7 centimeters tall and we have to account for the hole in the middle of the cake. You can then solve for the a value, or the coefficient, by plugging in the point 3, 0, which is a 0 on the graph because the width is 6 centimeters and this gives you the value negative 7 over 9. To find the area of this cross-section, you can do the FGC, which will tell you that the area is 28 centimeters squared. To find the volume, you can use the shell method, which gives you the answer 1,055.575 centimeters cubed. As you can see, this is the best cake because it's so easy to get the volume and area of.
Wait, you're supposed to be standing right here.
So have you guys decided? Thank you.
Yeah.